one is already starting. Okay.
Tu peux dire que s'ils veulent gagner du temps et que sinon les liens sont sur Slack s'ils sont sur le Slack. Hello everyone. As we are waiting for the last person. Hello everyone. Yeah. It's okay. Speak closer. Okay, great. As we're waiting for the last person, there are some links if you want to take a bit of time savings, because it can take a bit of time to build, or they are in the Slack channel too, if you're on the...
Welcome back to our second tutorial slot. Next two speakers are Stephanie and Sarah. They work at people.by Ultimate Software, and one of the problems they've been working at is sort of improving the process of versioning models and getting them running in production. They build a pretty cool open source package surrounding this, build on some other nice little technologies like data version control. And I think that's also what they're going to show, how to use this and how to use the technologies underlying. So please, warm hand of applause.
So, hi everyone. We will talk about how to set up a development environment for a machine learning project. I'm Stephanie. I've been a software engineer for 6 years. I have a strong interest in automation and code quality.
Hi, I'm Sarah, so I'm working with Stephanie. So I'm more of a data scientist. So I'm not a software engineer. I have some interest in some of this issue, but I'm more focused on all this data science and machine learning stuff. And actually, when I was working on my machine learning problems, I've got some recurring issues, which is like, how can I version things? How can I version my data? And also, I really like to use Jupyter notebooks for exploratory analysis, and I want to version that, but I want to version that in a sustainable way. I don't want to open Jupyter notebooks 2 months after and like nothing is running and everything is broken. That's no use. I want to be able then, after these exploratory steps, to be able to automate the pipeline execution and to rerun it with new hyperparameters very easily. And that's also something Jupyter Notebook is not so good at, because you tend to have like multiple copies where you change your learning rate and then you just version everything in the name of a notebook, and it's really messy. So it was like, I need some help with that. And then I want to be able to reproduce easily the experiments I ran in the past and share them with other people, other data scientists. really easily. And that was how things were when I arrived at PeopleDoc as the first data scientist. There was nothing to set up, and I was like, okay, I need to to set up something. And so we'll start with the pipeline and data versioning issue, which is my drive typically looks something like that. So I've got some CSV data and I've got a lot of versions, and I try to put in the name of the file what is in the data, but then 2 months after I'm not sure if I should use the final or the final two, or is the final two something I tried but didn't really work, and it's really messy and get a lot of problems. Also, that's that trickier, which is I managed to, maybe there is some solution like Git large file system to version large files, as the name says. And so maybe I managed to version that properly. And I've got this like raw data and then preprocessed data. But then if you have a look, you see that the preprocessed data is actually older than the new raw data. So I probably forgot to rerun the preprocessing step when the raw data was updated. And that's another thing which is which I would like to automate and avoid like any risks of inconsistencies and just being in your pipelines and like, what did I do to get this result? Because it was a nice one. I want to have it again, but I've got no clue how I did it. So.
Yeah, and so to solve those problems, we will show you how DVC, data version control, works. It's an open source versioning tools for data in machine learning project and other projects. It's a tool for data scientists, made by data scientists. It's available on GitHub, and you can find a nice video about how it works. We can't see it now because we don't have the time, but we will share the slide, and you will have the link. So globally, how DVC works, it's a versioning tool. It helps you to automate a pipeline and version intermediate results and all the results. It handles experience management, as you can do with Git branches. And it's a tool to share your pipeline with your teammates. I will not enter in details on DVC features because we will show you how it works during the tutorial. But you can, if you have questions, do not hesitate to ask during the tutorial session. But just to illustrate how it works, we can imagine we have a pipeline with a really time-consuming task at the beginning, which is a data extraction step. It produces some raw data. Then there is a preprocessing step, which takes as input some hyperparameters and the raw data, and it produces preprocessed data and etc. until we generate the metrics. So here DVC version all intermediate results. And for example, if you want to change some hyperparameters and reproduce the metrics, you just need to say to DVC, I want to rerun the evaluation step, and you don't need to care about which step I need to run first and which step is outdated. It detects them automatically and only rerun needed steps. So you avoid to rerun time-consuming tasks, and you don't need to remember which step you need to run to reach the target. So now we will talk about how DVC works. The main command is a DVC run, and we will switch on the tutorial part.
Yeah, so there will be two main parts of the tutorial. So the first is an introduction on how to use DVC because we use it in MLV-tools, and the second part is more focused on actually using our open source project, which is MLV-tools. And there's a lot of materials in both of these tutorials, so we won't cover everything. But we hope that you will get enough to get started and then be able to continue at home if you're interested. And we're also available, so the rest of the weekend, and then afterwards by emails if you've got any questions on the tutorial or something which is not working or not clearly enough explained, or that kind of thing. So.
Okay, so I don't know if everyone has cloned the MLV-tool tutorial repository, but we will work on it. So if you can just go in this directory, and I will switch on the tutorial part. Just if you can build Docker images before I begin to talk, we'll avoid to waste time.
And all the links are in the Slack.
All the links are in the Slack general channel. So as Sarah said, in this tutorial, the aim is not to do everything, all the 4 steps, but after that, you will have an environment to do your own experiments and to be more familiar with DVC and how it works to demystify the mechanism. So the aim of this tutorial is to create a pipeline with DVC, then to show you how to reproduce a pipeline with some input changes. Then if we have the time, we will set up a DVC remote storage to be able to collaborate with your teammates. Okay, so now I just spawned all containers. So here we have an environment with 2 users, DVC server. Oh, sorry. You're welcome. To set DVC server for the step where we will set up DVC remote storage and a Git server to host the Git repository. So here I will show you the 4 containers. Here the Git server is the DVC server, and at the bottom the 2 users. But you don't need to go on all containers. For the tutorial, you just need to go on the first user as it is described here.
And if you get any problem, just raise your hand. I will come and try to help.
Okay, so here I will just display the size of the Git repository on the Git server. Here's the size of the DVC repository on the DVC server. And here I can connect to the first user, which is Sengoku. Okay, so the first step is to go in the home directory, then to clone the Git project. Which is empty, and to go inside this project. Okay. Now, the first step with DVC is it's to be in a Git project, then to initialize this project with DVC. It's pretty simple. You just need to run a DVC init. And now, if you run a Git status, you can see you have some DVC configuration file. We need to add them, then to commit. Okay.
So is this good for anybody to set up the Git and the DVC? Okay. Wait.
Do you need some help? Or?
So the things are in the yeah.
Here in the Slack general channel, you have the repository to clone,
And the link to the Markdown.
Then, yeah, we have the link to the tutorial here.
So it's not in that direct.
Sorry.
It's, tu peux remettre le slide?
Oh, sorry. Ça?
So what you're doing for now is this tutorial, this part of the tutorial. We're going step by step on this.
In the Markdown part of the tutorial, you have some details you can expand to see if your configuration is okay.
Is the setup of a Docker okay for everybody, or are there some problem having some people have a problem with Docker Compose?
To run the Docker Compose build command, you need to be in this directory. I think there's too much people on the Wi-Fi. Yeah, can you raise your hand if the Docker compose build step is okay? Okay.
It's still working.
Okay.
I saw some red though. It said it complained about it said packet apt-get. It said something was delayed because apt-get wasn't ready. There it is. So this one.
Okay. No,
Or
I think it's
apt-utils, but
still
it's
okay.
not a problem.
Yeah.
It's just taken care of later.
During this time, I just will introduce.
So who has been able to set up a DVC and a Git repository yet? A few people?
Is it a question?
Who has some error on the Docker Compose, but it seems to be kind of working?
It's working.
Okay.
Still not connected. Well, you haven't seen it?
So, yeah, I will explain you what will be the pipeline we'll use in this tutorial. So it's really a simple pipeline. There is no link with machine learning. It's just to show how DVC handle a pipeline. So we will have two inputs, which are some files. I will show you what is in those inputs, and some parameters. The first step just concats input files, then generate an encrypted file, and the second step takes some parameters and the encrypted file to decrypt it. I'll show you the files. We have some characters in both files. Okay, it seems it's encrypted, and some parameter. It's not really an encryption. It's just some colon shift. You will see. So as I said, there is some checkpoints each time in the tutorial to see that it's okay. You have the data, for example. And now, if you can raise your hand if the Docker Compose build is okay.
Raise if it's okay.
Okay.
Maybe we can talk a bit about how DVC is working. The idea is something which is working alongside Git. So Git will be used to version all of your code and like normal stuff you put in a normal software engineering project. And DVC will be something alongside to version your data, because you don't want to put your 3 gigabytes files into Git, obviously, because it'll break everything. But you also want to have to keep in sync your data files and your code files, your regular things. And so how do DVC do that is generates each time a metadata file. Maybe you have some...
Yeah, no, not here. But
here you see. So it's all these metadata files are like ended with .dvc as an extension. And these are the files DVC is using to version your data alongside of Git. So Git will version these .dvc metadata files and all your .py and bash files and so on. And DVC will manage to have a cache mechanism from which they can take the metadata files and recreate the real data files. And that's basically the idea. And so every time you do something on Git, you should do the same on DVC. So like you do a Git init, then you do a DVC init. When you do a Git checkout, you do a DVC checkout because you have to keep these two mechanisms in sync at all time. I don't know if you want to add something.
no, maybe I will show it with the next step. But
I have a question.
yeah.
So can we do DVC add in the folder instead of each file separately, or what is the difference between that?
In which folder you would?
Doing DVC add data inputs versus doing 3 DVC adds. Just add the whole folder at once.
Oh yeah, yes. You can add the folders just to really show all the steps.
Okay, but it is equivalent.
Yeah, in fact, if you add the folder, if you just add file by file, the dependency is on the file. If you add the folder, the dependency will be on the folder. So if you add something, another file in the folder, steps in relation with those dependencies will be outdated. So if you add file by file, the step is outdated only if you make a change in the file. Maybe I can just run those 3 commands to show you DVC metadata files. So just to remember, I'm in the Git repository, and I just added inputs data, and I will track them with DVC. So I just need to run a DVC add data inputs, so parameters, for example. We need here to add those files because they are pipeline input files. You don't need to do it for intermediate files. So here, if we run a git status, you can see we have a data repository. I will run all the DVC add. Oops. Okay. If I add the data repository, normally if I do that without any DVC action before, I will track the data under Git. It's what I don't want to do. But if I do that here, oops, and I run a git status, you can see here data are not tracked. Why? Because when you run a DVC add, it will create a DVC meta file, which takes the name of the input plus the extension .dvc, and it creates a gitignore file. And in this gitignore, you can see there is the real data file, parameter.json, part1.input, part2.input. And if we look in the meta file, it's an internal DVC mechanism. All version of a file is identified with a hash, and the real path to the data. And if we go deeper in the .dvc directory, oops, there is a cache directory. And in this cache directory, you can find hard links to the real data. Sorry. So if we go in E9, like the two first character here, we can find the other part of the hash. And if we display that, you can see it's this version of the parameter.json file.
But you don't need to understand all of that to use DVC,
Yeah.
because
No.
I don't.
It's just to go deeper while we are waiting for the Docker Compose build. Now, where are we? Is it okay for everybody?
Yeah. So, and the people who managed to get the Docker, did you manage to init the DVC repository and add the input? Good? Great.
Okay. So we are.
Or share your screen or something.
Sorry. So now we, once the DVC init step command is run, the project is set up with DVC and we can begin. So you can just get the input data, run the DVC add, and then commit the DVC meta files. So now if I run a git log, I can see my commits. And if I run a git status, it's okay, everything is tracked. Is it okay? So now for the first step, we will, which is the concatenation, the file concatenation. We need to get the script. You just need to create a step directory and copy the script from resources. So this script is just a Python command. You can just do something like steps concat file -h. It's a Python command which takes as input an input directory, and it will produce an output file, which is a concatenated file. We can see that it's a pretty simple Python code. Okay, so now we will add this file and commit it. So this file, it's code file, so it's tracked with Git, no DVC here. And now we will run the DVC step. So first we'll create the intermediate result directory. And here we have the DVC step. It's really tedious to write. In fact, you need to provide to DVC a command, which is in the step 1 variable. And you need to declare dependencies and outputs. So you will create a step which know which are the file you need to run and what it will produce. It's like that you will be able to know if a step, well, DVC will be able to know with that if a step is outdated or not.
Yeah, but use that to create this dependency graph you've seen at the beginning.
Yeah.
Maybe you can show. And so now you're telling in this first step you've got 2 inputs and 1 output, and so you can build the graph and handle automatically then your outdated dependencies afterwards. But when you build it, it's a bit tedious to write.
Yeah, you need to declare dependency here, but you also need to provide it as an input of the script. You need to declare output, and you need to provide it as the output of the Python script. But now we can run that. Okay, so if you run a tree, you can see there is a new file in intermediate results. We can just display it. Okay, it's some characters. No surprise, it's just a concat.
Does everybody who managed to set up the DVC got to this encrypted file? Good? Good, good.
Okay. So now,
Is there any
sorry.
question?
Okay. If I run a git status, I can see there is a new metadata file, and there is some data. I just can just add everything. We run a git status, and I can see only code files, well, no data files are tracked with Git. Once again, thanks to the Git in your file. And I can commit this first step execution. Just to show you that so the compose is working here. If I push the results, so I'm working on the master branch, but if I push the result, you will see this number will increase. Oops. Oh, I made a mistake. Oh, sorry. Okay, now it's 288. Do you have questions? Do you need some help? Yes?
I'm confused about the relationship between Git and DVC. What, like, you're using DVC, but then you can do Git add, and sometimes you do DVC
Okay.
add.
Yeah, in fact, DVC works with Git. You will continue to handle your project like you do on the project code with Git for all parameters, files, and for all Git in your files or code files and things like that. But file considered as inputs or data in the pipeline are handled with DVC. So the real file go in the DVC storage, and to each data file, there is a metadata file which is associated, and this metadata file is handled under Git, like it's done in Git large, Git LFS. So with this mechanism, you will be able to, create a new experiment, run a Git checkout on a new branch, change your data, so a new meta file will be generated, and this meta file is tracked under Git. And if you check out your project on another computer, you will have this meta file under Git, and then you can run a DVC checkout. It can go to read the meta file to get the corresponding hash and check out the right data.
So you're not actually pushing the data itself,
No.
you're pushing the metadata,
Yeah.
and the metadata knows where to find it.
Yeah, for now, in this step, the data is just in the cache directory, the .dvc/cache directory. And when we will set up the DVC remote storage, data will be stored here in this in the DVC server.
Can I ask another question about this relationship between Git and DVC? Because you really have to pay attention that you always commit
Yeah, there is a risk of inconsistency if you forget to track the metadata files.
Is there some kind of trick or tool that you keep these synced?
In fact, it's the purpose of this tutorial. For now, we will just want to show you how DVC works and why it's a great tool, but it's really tedious to set up. There is a lot of risk of inconsistency. So it's for that we develop MLV-tools to help you handle and easily set up your project with DVC from Python scripts on Jupyter notebooks. Okay.
So it's okay for everybody for step 1? So after step 1 comes step 2?
Yeah, so now we will decrypt this file. So once again, you need to get a script from the resource directory and version it with Git. Okay. It's just a Python script, a Python command, which takes as input an encrypted file and a parameter file, and which creates a result file. So here we have the DVC command. So once again, DVC run -d dependencies, encrypted file, JSON parameter, which are also here, provided to the Python command, and the output file. And when you will look at the result file, just be sure you don't zoom too much on your terminal. Yes?
Yeah,
Is the second step okay for everybody? No?
Who's struggling with the second step? Okay, who's completed it?
Can I display the results? Okay. It's a sad unicorn. But maybe there is a teammate who will apply happiness. I don't know. I don't know if we will have the time. So once again, if you run a git status, you can see there is a new git in your file and a new meta file. You can add them, then commit them. If you run a git show, just to really show you there is no data on your commit, you can run a git show on your previous commit. And here you can see there is no unicorn, just meta files. Yes?
What happens if you run this, if you do DVC run without defining dependencies?
It will be a step without dependencies, so nothing come out that it will be never outdated.
Okay, so it means by defining dependencies every time I change the so because what's the purpose of the dependencies? If I change the dependency file, does something happen, or?
In fact, if you I will show you that. If you change the dependency file, you can run after that a DVC status to see which steps are outdated, and it will say you it's not okay. Or even if you don't run a DVC status, you just say I want to reproduce this step. It will look at all step independencies and rerun the needed one. To continue in the ASCII art part, you can display the pipeline with the DVC command, which is DVC pipeline show with the ---- ASCII arguments on the last metadata file which corresponds to the last step of the pipeline. And whoa. You can see part 1 and part 2 stages, which correspond to the pipeline inputs, are inputs of the file encrypted .dvc steps, and JSON parameter and the file encrypted are inputs of the result steps. So is it okay for everybody? For the next part of the tutorial, maybe I will just show you, because we don't have a lot of time. And but you can reproduce it at home, and do not hesitate to send us emails if you have a question of if you are stuck on some part of the tutorial. So, like I said, the aim of DVC is to be able to reproduce a pipeline easily, and there is a DVC repro command. So now if I run DVC repro and I provide to this command the meta file corresponding to the last pipeline step, I can see nothing happened because there is a cache mechanism and all steps are not outdated. But I can force the rerun, disable the cache with the -F option, and everything is rerun. But now, if I change some data in the JSON parameter file, oops. Okay. So I can say the call odd shift is 165. Okay. If I run a DVC status, it says that the parameter.json stage is outdated. It's a pipeline input. And so the result stage is outdated too, because parameter.json is a dependency of this stage. If we just have a look at the pipeline schema here, you can see parameter.json file is an input of the decrypt steps, which is a result.txt.dvc step. Now, if I re-add pipeline input, oops. If I run a git status, I can see.
Never do live coding.
I can see the meta file is modified. I can run a GIF on it. There is a new MD5. And now, if I say to DVC to reproduce the result step without -F option, I can say it runs the step. It runs the step. I can see the result. And I'm really not happy with this result. And okay. As DVC is working with Git, I can just run a Git checkout.
That's a oops, I broke my neural network moment.
So there is no more modification on the parameter.json metadata and result metadata. But if I display my unicorn, it's still not the right result. It's just because each time you run a Git checkout, you need to run a DVC checkout. So we can read metadata files and resync data, real data file. Here, if I run a DVC status, it says there is changes. If I run a DVC checkout, I can display again my unicorn.
Okay, so we're gonna stop here for DVC. So if you want to continue the tutorial at home later, there are 2 additional steps in this tutorial, which is about setting up a remote data storage. So remote, quote unquote, because it will be like just another Docker in the Docker Compose, but that could be anything from Google storage, AWS, or SFTP files storage if you want to keep your data private or that kind of things. And then how you can collaborate using this remote storage across teammates. So that's really like a playground you can use to try to really understand how DVC works. And so yeah, we'll be happy to hear if you have like some questions when you're playing with this thing. And so as you can see, DVC is a very, very powerful tool. And we are really glad to see to find this tool, but it can be a bit tedious to use in the day-to-day. So even if you've got already everything set up in command line steps, you have to write all the dependencies and the outputs, and usually like your command line step take input and output, so you have to write everything twice. And be sure that you don't make any typos, or else your reproducibility will break, and you don't want that. And so with Stephanie, we started to think about what we could do to make it easier to use, especially for like data scientists who don't want to do so much of thinking about like bash variables and that kind of things, and scripts that always break. We want something easy. So we developed this command, which is called GenDVC, and help you to generate a DVC file. And so this script underscore DVC file is an executable file. You can then just run it as a command. And so that's very easy to use. The other thing we had was this Jupyter Notebook problem, also called Jupyter Notebook problem, which is like Jupyter Notebooks can be very great, but they're not sustainable if you want to go all the way to production, because they're hard to version. I mean, every time you rerun it, you've got like slight change, which are most of the time noise. So if you want to commit them like that, it's always changing and messy because you don't have exactly the same minor version as the other person or that kind of things. If you want to do some unit testing, it's terrible. And if you're working with a software engineer and don't do unit testing, you get beaten a lot. So like, okay, we've got to write some tests and we can't write them on Jupyter Notebooks. And if you just try to like copy paste your code from Jupyter Notebooks to a library, it tends to get out of sync. It's hard to debug. So you want something which is more automated than that. And so that's why we have this ipynb to Python command. So obviously you don't have to say it out loud to use it. Yes?
Yeah, but with UP-text, you only can you can create a parameterable and executable script from the Jupyter Notebook. We don't really have the time to go deeper in the EPYNB to Python command here, but it will create a Python command with some parameters. You can run it with a -h in your terminal and see arguments. And all the code will be in a parameterable, configurable method, function. Sorry. And you can, with EPYNB to Python, you can disable no effect statements. And I don't know if it's possible with UPText. But before developing this command, we have a look on what is existing. And EPYNB to Python is based on NB convert from Jupyter.
Yeah, and so basically you've got from this notebook to the scripts. And then if you're extra lazy, we've got this magical command, which is like, you go from the notebook directly to the DVC command, and then you can just version things quite easily. So that's the second part of the tutorial. So it's totally independent from the first part. So even if you got problem with Docker on DVC, you can start again. So the link is the second one on Slack.
Yes. So this link.
That's the setup project part. And so you can set up, there's a Docker if you've got some problems, or you can set up your favorite virtual env or coder env, and we've got a requirement file which you can install.
Yeah, if you want to use the Docker container, you can run this command just to build it and start it, and go to the tuto directory.
And if you hate Docker because it's never working right on your computer, just create copy the raw sources in a separate repository. We call it sandbox, but
yeah. So in the MLV-tool Git, you need to go in the MLV-tool tutorials Git root directory.
Yeah. So you should be in the DVC playground. So you need to go up twice, I think, or once.
I don't know. Just you can shut down your Docker Compose environment. And so you can just run the copy paste these commands. It's just to create a sandbox environment, copy resources, go in the project and init the project with Git, add everything, and perform the first commit.
And then you can create either a vend or conda end if you're more use.
We will explain after that things about the tutorial, but if you can run this part before we talk about the pipeline, it will be great, because there is a time-consuming task here with the setup.
Yeah, especially if you're using conda, they tend to copy everything, so it takes a bit of time to download.
Yeah, and the Docker images is provided, because if you don't run in the Docker container and Python 3 -dev is not installed on your computer, maybe you will have an issue with the setup. There is no issue with the conda env, because conda handle dependencies. So during this setup test, we will talk about the tutorial on its aim. Maybe, Sarah, you want to introduce it?
So the goal is to start with a typical state of a project, like when you're doing some exploratory analysis, and then you want to tidy things up and go all the way to have a production-ready pipeline. So we will cover a few things, mostly how to get from Jupyter notebooks to scripts, and then to scripts to DVC versioning, and then I don't know if we're gonna have time to do the other things, but same as with the DVC playground tutorial, don't hesitate to continue and ask if you've got questions afterwards. So this is really a toy project. It's based on TripAdvisor review, which are available in a JSON format. And each of these review is associated with a star rating from 1 to 5. So we're going to do classification because there's only 5 classes. And yeah, basically, I mean, it's a choice you can discuss. But the thing is, we're not trying to do like high-level data science. We're just trying to showcase how things can be done. And we've got a few steps. So we're going to first extract things from the a JSON format to a format which is going to be more easy to use for training. For training, we're going to use a Facebook library called FastText to do some classification, basically because they took files as input and output files, and so that's a good showcase for our example. And obviously, we're going to generate some metrics at the end to know how good we did. I think that's pretty much it. Yep. Has everybody managed to at least start the installation of the environment? Can you raise your hand if it's okay? Good. So if you have a look at the project structure, probably be something like that. So you've got some notebooks, which are like the different steps you want to do. And you already started to extract a bit of these notebooks to a library for sharing, like loading and saving models, functions, and that kind of things. But it's, well, it's in a mixed, half-baked state between really dirty and really clean. And so we want to try to improve that.
Yes. So here enter the MLV tools. So first step, we need to run a DVC in it. So initialize DVC in the project. Okay, so here I am in the project. I already copy data. Yeah, sorry. And make the initialization file step. So I can run DVC in it. I get status. Oops. Okay. So the first thing to do, it's an optional step, but we will do it to because it will be easier next in the tutorial. We need to create a MLV-tools configuration file. This file is used to generate path for the Python scripts and DVC command to automatically generate them based on the path provided in the configuration file and on the Jupyter notebook name. But it's totally optional. You can, each time you run a command, provide this the output file you want. There is more documentation about this configuration file on a MLV tool Git repository in the README part. But just trust me for this step. You can just copy paste those lines in a file named .mlv-tools in the Git root directory, and then add it and commit it. Oops. Okay. Then we will create directories for the script and the DVC, for the Python script and the DVC commands, and get the data for the pipeline. Okay, yeah.
And now
I have the data, which are a configuration file and the TripAdvisor reviews. Then I have the Python resources, the notebooks, and the pipeline structure.
And now we can do the fun part and have a look at what is in the notebooks.
Yes, it's your part.
we have any questions so far? Yes?
Where do I run the novice server?
Uh,
I did the Docker frame, but running it inside Docker gives me an error on bind address.
Yeah, because you don't have, you have to link the
Oops. Sorry, I didn't think about that when I create the Docker container. Maybe
You can always edit the notebook by hand.
no way. Yeah, you can run a Docker CP. I'm sorry for that. I totally forgot to link the. Or you can just expose 22 port. Restart the Docker, expose the 22 port, and say to Jupyter Notebooks to start Jupyter Notebooks on this port. Sorry.
Is there any other questions, problems? Okay, let's have a look at what we have here. So first, the extraction step. Can you read good enough? Should we make it bigger? Fine. Well, basically, we're using this very nice function with rote, which is gonna extract things. And so we've got the review, the raw files which are here, and the extracted data is there in a nicer format. And as you can see, well, it's kind of clean, so it should work. So we've got data, a lot of things. We've got 369 samples. I can extract it. So we got from this JSON raw file to something which is broken sentences by sentences with the ratings at the beginning in a tuple. And so let's check. Oh, we've got the same number of samples. My function is working perfectly. That's a good unit test, and just check things by hand. Very good. And I can save this thing. And the problem is that my inputs and my outputs are spread out all over the notebook. So when I open the notebook, when I open the notebook, I know what's happening because I understand I wrote the notebook, but when Stephanie is coming from another project, opening quickly the notebook, she's like, what's the input, what's the output, what's happening? And, well, we can have a look at the other one, which is pretty much the same for everything. There are things spread out all over the notebook.
Yeah. So there's just you can go through the steps.
And yeah, so there is like all the steps we are shown. So you extract, you preprocess, you split, you can train, and then you can evaluate your model. And so what we want to do first is like to identify everything which is input, outputs, parameters, and then put them at the top.
Yeah, you need to remove hard-coded values from your notebooks. It's just the first step to use MLV-tools. You need to have something like configurable notebooks. See if, from the first cell, which are inputs, outputs, and parameters, what you can change in this code to generate another thing. What is the dependencies of this step?
Do you have some questions?
So.
So we're going to do the first notebook together, and then you can do the other one because it's a really fun activity. So basically the input is good, and we want to extract the output, so we just put it at top in the variable, and we're good to go.
It was in this notebook, so for the example, sorry. So yeah, we can get this path. just create an extracted data path variable. Okay, it's really simple, and replace it.
So we're going to need to do that for all of the notebooks, so it might seem a bit boring, but actually that's because we are going in afterwards. If you just take the habits of always putting all the external variables at the top, when you're writing, it gets easier and easier.
In the modification to do, there is a little trap in split dataset. Here there is a parameter. It's not an IO, but it needs to be in the first cell if you want to change it so sometimes, because it's where we want to split bit for the train and to split the train and the test set. But you can do it by hand, but just because we don't really have the time, there is a shortcut here, and you can copy configurable notebooks from the solution.
So is everything good for everybody till that?
Now we can version notebooks, configurable notebooks, with Git.
And so if you go back to the notebook server,
you can see now there is IO here, input outputs, and parameters. So here there is no MLV tool, it's just remove hard-coded path, remove hard-coded parameters from your notebooks.
and now to be able to use the MLV tools, we need, it's quite magical, but you still need to write some things.
Yeah. So as we said before, there is 3 main commands in MLV tools. You can see them in the MLV tool documentation, but here we will use the command to generate both Python configurable and executable script and the DVC command.
And so we need to add some information. How do we add some information to help MLV tools is just we add a docstring to specify which variables are parameters.
So if we take as an example the split dataset notebook, you can see there is this information in the first code cell, and we will need to say to MLV tool which variables are script parameters. And we will do that through the docstring. So the syntax is this one. There is some optional things like the parameter type and the parameter description. We will have this thing in the first code cell. So I will explain it. I copy paste it here. So here. Okay. Here we have preprocessed data path, which is an input of this notebook, and we can declare it as a Python argument, saying it's a string arguments. We provide its name, and a short description. Same thing for train dataset path, which is an output, test dataset path, and test %, which is a float, and which is an argument of the...
An hyperparameter.
An hyperparameter, yeah. I can save the notebook. So this thing is to say to MLV tool which will be parameter for the Python 3 executable command. It's needed by the epynb to Python command, to the epynb to Python MLV tools tool.
So that then you generate this Python script, you can actually provide all these parameters to the Python script if like you want to rerun the step and increase the test size and use .2 instead of .15. You don't have to rewrite or open and change hard-coded value in your notebooks. You can just change things on the fly.
But if you want to also generate the DVC command, you need to say to DVC which parameters are DVC dependencies, DVC step dependencies, and DVC step outputs. So you need to add some information in the docstring. So here, this part. Okay. So about the syntax, here we have a DVC in, which is a DVC dependency. So preprocessed data path, which is also here, is a dependency of this step. So we need to declare it. And we provide the path to this file relative to the top, to the Git repository root dir. And same principle with the output path, output files. And we can provide some extra parameters because the Python command needs the test % argument. All things in this cell after the docstring will be discarded in the Python script. Those values are just for the purpose of the notebook, just so you are still able to run it in the notebook. And you can see paths are not exactly the same because we are not in the top level directory here. Yeah, there is something more here. This docstring can use Jinja templating. We will not show it here, but it's in the documentation. So you can use variable here from a configuration file and reuse those variable here. So there is no inconsistency, no risk of inconsistency. But it's another subject.
And just as it can seem like a bit too a lot of to write, but actually it can help you to like sequence how your pipeline is going and makes you think about which are the dependencies of each step and your dependency graph. And it's really interesting also from a data science point of view to have this vision of how things are flowing through and which are shared dependencies and which are distinct dependencies. And it's actually like you write it once and it's not that long because then you can reuse your notebooks and you're not always starting from scratch. For example, this preprocessing step can be the same for all of your training pipelines if you've got the same input data. So it's a bit of work, but at the beginning, but you win a lot of time afterwards because things get easier and faster.
Yeah, all information are centralized in the notebook.
Is there any questions or anything which seems unclear?
Then if it's okay, I will show you the result. I will generate the Python script and the DVC command from this notebook. So I run the epynb to DVC command with the notebook as input, and I let the script generate output path with the configuration file. Okay, now if I run a tree on the pipeline structure, I can see there is a DVC command and a Python script. Okay, no surprise. The Python script is in fact a command. You can retrieve arguments, preprocessed data path with a short description, etc. And we can have a look at the DVC command, but it's quite complex because there is some mechanism you don't really need to know about. But here is the DVC step call, DVC run step call with a Python command and the reuse of variables. But we don't have to know what happened here. But there is something wrong here. If we have a look at the Python script, we can see there is a lot of we can see there is a lot of no effect statement. We don't want this kind of statement in a non-interactive run. There is no interest.
But you still want to keep them in the notebooks because when you are developing or when we are debugging, we want to be able to have the length of the things, or a show on our data frame, or maybe some nice histogram plots, or that kind of things. So we don't want to remove them entirely, but we don't want to have them in our automated pipeline run.
So to discard this kind of statement, you can add this comment in the cell, in the notebook cell you want to discard, and they will be removed from the generated Python script. So in the configuration file, if you don't want to say no effect and you want to say the discard word is unicorn, you can configure it. Okay. Oops. So like that, you are still able to run this cell in your notebooks, but if I regenerate files with a -f because they already exist, I can see now. I forgot one, but there is no no effect cells are discarded.
I've got yes.
Interesting setup. I mean, my question would be, how do you encourage people to reuse code? Because now multiple notebooks could define the same behavior approximately, and there wouldn't be a big reason to unify that in an importable package.
Well, I think if you want really some unit testing, it's still easier to do that only once, because these kind of scripts are really good for functional testing, but you can't really like test unitary each micro step.
But like reusing code, so extracting code from a notebook to a package, I mean, how do you encourage that if you use this kind of workflow?
I think you need to find a balance between function, for example, like split dataset here you want to put in the Python module to reuse it, but maybe you want to run a functional test on this step, and you can do it because there is a function here which represents the notebook execution.
But maybe the thing would be like a typical workflow. I mean, we want to version things at all steps, starting from the very exploratory thing all the way to the production setting. And the idea is, obviously, when you're in the very really exploratory step, you can version things using MLV-tools, but you don't have, you have few tests and that kind of thing. And the idea is, as your pipeline gets more mature, you are encouraged to take out things from the notebook. And in the end, in our production-ready notebooks, we've got like 2 cells in our script, which are this docstring cell, and the other cell is like import this function from our library and use it on the input. And then you've got all these cells below, which might be there or not, which are no effect cells, and which are like, now that I run this, for example, pre-processing step, I want to check that everything went right, because it's like new customer that I've never seen before. And I'm still using the same Jupyter notebook, but when it's a script, it's like a very short script, and everything is outsourced to this library, to this Python module, which is tested. But when I'm running on new data, I can get this, I can do my import pandas and have a look at my data frame and check everything and check how many missing values I have and plot all the things I want to have in the notebook. All this like data monitoring things we want to do, and it's still available every time in the same notebook, which is shared by everyone. But the script in itself, there's basically no code left in the notebook. It's just like a Windows open on your data to check what is happening at every step of the pipeline.
Yeah, we don't have a lot of time. I just take the shortcut to yeah, you can copy all notebooks with MLV-tool doctrine and generate all those notebooks, all the pipeline script, pipeline Python script and the DVC step. And so here you have this structure with Python script and DVC steps. I just want to show you how to run the pipeline. So I add everything under Git. Oops. Okay. So now I can track pipeline inputs with DVC, as we did it in the DVC tutorial part. And then just run each DVC step we have generated in the pipeline structure. I'll go quickly.
So we just remove intermediary results because or else they will consider it's already here, and so we get an error and you need to rerun the step with -f. And since there are a lot of steps, we don't want to rerun them. We just want to copy paste thing.
Just to show you, we have a DVC pipeline. No, sorry. DVC pipeline show. You can see here we have a DVC pipeline. Yeah. Okay. So I'm sorry, it's too long and we can't explain everything. But with those DVC command you run once on your project, you can build DVC pipeline with all information centralized in your notebooks. And with the script, you can take advantages of your development environment for refactoring and things like that to know where functions are used. You can write tests, and after that you can use the feature of DVC and reproduce any experiments.
And yeah, just to the end of this tutorial, which we won't have time to finish, if you go back to the pipeline thing, yeah, and which is not just about writing tests, because we don't like to write tests, but the very magical thing is if I change something in my configuration file, like if I change, so in the train step, we're going to use a learning rate, like basically almost every machine learning algorithm. And if you want to tweak your learning rates when you're trying, what you can do is basically just create a new Git branch and change this value, add the file with DVC with the new value, and then rerun the experiment. And you can have all of your experiments which are versioned side by side, and so that you can check which learning rate is working best. And that's really powerful, because then you can iterate really quickly with a lot of confidence about, like, I'm not mistaken. I can run experiments even quite late in the night, and I'm confident that I'm not using the wrong file, and then my experiment is running all night, and in the morning I'm like, oh no, that's not what I wanted to run. So
you can compare results after between each branches for.
Yeah, and that's really the one of the strong points of using DVC, is having this possibility to explore a huge tree of combination of hyperparameters, and then in the end choose which one is working best and merge it back into your main master branch. And you don't have to keep track. I don't know how you were doing it, but I was doing it with like an Excel file or something, where you enter by hand hyperparameters and try to see which one is the best, and then you try to do this grid thing, and it just gets messier and messier. At some time you're like, okay, I will just pick one combination at random and hope it's quite good. it really allows you to iterate more quickly and get better results much faster.
And there is other feature in MLV-tools. You can export a pipeline. Soon you will be able to export a pipeline and package this pipeline with Debian packages or Conda packages. It's under development. You can also add a git hook command to check there is always a consistency between your generated script and the Jupyter notebooks, because it's essential. And we are really waiting for your pull request or for your feature request.
Yeah, I mean, if you don't feel like writing a PR, but you've got this use case which is really important to you and it's not covered, we definitely want to hear about that to be able to see if we can.
And there is still a lot of things to improve. For example, we can use Jupyter Notebook tags instead of comments to discard no effect cells and things like that. And
thank you.
That's all. Thank you.
Platters served around the area, just grab a bite and we'll see you back in a minute. Thanks. Went well?